Alright, so in this video we are going to learn about how to verify or how to prove trigonometric identities. So right here the identity is given, which is cosecant squared x minus 1 over cosecant squared x should be equals to cos squared x. This topic is same as simplifying trigonometric expressions. The method is same, the ideas are same, but the difference is here you have two sides, left hand side and right hand side. So how it's gonna work? You will start this question with any side. So let's say if I'm starting with left hand side, so I'm going to write left hand side. So the left hand side is cosecant squared x minus 1 over cosecant squared x. Okay, I will simplify the left hand side and I should be ended with right hand side. That will shows that I proved a trigonometric identity. Okay. Alright, we are going to simplify this stuff with the same way that we were doing before. Now we have cosecant squared x minus 1. We should remember this identity that we did before, which is called Pythagorean identity. It is cosecant squared x equals to cot squared x plus 1. This is a Pythagorean identity. If I will rearrange this identity, it's going to be cosecant squared x minus 1 equals to cot squared x. Okay, now I will use this identity into the given expression and it's going to be cot squared x over cosecant squared x. Okay, now we are going to use another identity on cot squared x. We know what is cot squared x equals to. Cot squared x is cos squared x over sin squared x, and cosecant squared x is equals to 1 over sin squared x. Okay, this expression for this one and this for this one. So what do we ended up with? Sin squared x is cancelled out and we are having cos squared x. And look, what is cos squared x? Cos squared x is our right hand side. It means we prove the identity. So this is how we are going to prove the identities. Here we have another identity that we need to prove. Okay, so as I did in a previous question, I started with left hand side and I ended up with right hand side, correct? But you does not have to start with the left hand side and end up with the right hand side. The trick is, or the strategy is, you always start from the complicated side. So like right here you can clearly see right side is the complicated side. So I will start with the right hand side and I will try to end up with the left hand side. Alright, so let's start with this. Right hand side is, I will rewrite, it's 1 over cosecant x plus cot x plus 1 over cosecant x minus cot x. This is what we have. Now what do you see? We have two fractions, and whenever we have fractions we try to make same denominator. How do we make same denominator? I will multiply this denominator with this term, but in numerator and denominator both. Okay, and I will multiply this denominator with this term, but numerator and denominator both. Okay, I drew the arrow so you guys can understand what I'm talking about. Alright, let's do it. So I will multiply this term 1 over cosecant x plus cot x. I will multiply this term with cosecant x minus cot x over cosecant x minus cot x, and I will multiply this term with the other denominator. So cosecant x plus cot x over cosecant x plus cot x. Alright, now let's combine them. When you will combine them, it's going to be cosecant x minus cot x plus cosecant x plus cot x over cosecant x minus cot x and cosecant x plus cot x. Now if you remember the formula from my previous videos that we were using, a squared minus b squared is equals to a plus b and a minus b. Now right here you have exact this form. You can see that this thing is presenting a minus b, this thing is presenting a plus b, right? Now this thing will change into this form. Okay, so I'm going to erase these arrows and I will write it on the next step of your question. Alright, so you're going to have, putting this arrow, this thing present, this is your next step. Okay, so we're going to have secant x minus cot x plus cot x will cancel out each other, plus cosecant x over, this will change into cosecant squared x minus cot squared x. Okay, alright, now if again the identity we just used, Pythagorean identity, cosecant squared x equals to cot squared x plus 1. If I will rearrange this identity, it's going to be cosecant squared x and minus cot squared x equals to 1, right? I will use this identity in denominator, but what is happening in numerator? Cosecant x plus cosecant x will become 2 cosecant x over 1, which is actually 2 cosecant x. Now look at this in your question. We were calculating, oh sorry, my bad, I forgot to write 2 cosecant x. My question was wrong. It's 2 cosecant x. Now you can see that we proved that right hand side is equal to left hand side, and we proved the identity. So this is how we are going to do to proving or verifying trigonometric identities. Alright, so now we are going to prove or verify this identity. I'm going to start with doesn't matter, right hand side or the left hand right. Okay, so I'm going to start with the left hand side. Sin x over 1 minus cos x. Alright, now if you see in this situation, you don't have squared on this trigonometric functions that you can apply Pythagorean identity, and also you don't have two fractions that you will combine the denominator and you make the similar denominator and like try to simplify it. In this situation, it's a method called multiplying with a conjugate. Okay, so what is multiplying with a conjugate? When you have a term in numerator or denominator with showing two terms, like look at in denominator, it has 1 minus cos x, right? So the conjugate will be, you just switch the middle sign of these two terms, it will be 1 plus cos x. Okay, so when you will multiply and divide with this number or this term or this expression that is called multiplying with conjugate. Okay, this method called rationalization. Okay, this method called rationalization or multiplying with the conjugate, you can name any method, like they can ask you in many different ways. Okay, let's simplify this one. It's going to be sine x 1 plus cos x over, this is going to be 1 minus cos x and 1 plus cos x. Okay, now the next step is I'm going to simplify it. It's going to be sine x 1 plus cos x over, now what is this? Again, it's the same formula. It will change into 1 minus cos squared x. Okay, now add 1 minus cos squared x. If you remember Pythagorean identity, cos squared x is equals to 1. This is a Pythagorean identity. I will simplify it and it will become sine squared x is equals to 1 minus cos squared x. Right? Alright, I'm going to use this identity in a denominator, and it's going to be 1 plus cos x. This will become sine squared x. Okay, now let's simplify it. This squared will cancel out with this sine x, and you will left with 1 plus cos x over sine x. Okay, now let's distribute this term, like let's just split this fraction. You will have 1 over sine x plus cos x over sine x. Look, if you remember, when we make same denominators like this, we make same denominator and we just combine them and we can end it up with this thing, right? So we are just doing a reverse process, so we can just combine this term, simplify this term and try to get the right hand side, the one we have right here. Okay, so what is 1 over sine x? It's an identity which is equal to cosecant x plus what is cos x over sine x, that is cot x, and you could see that this is right hand side, and we proved, or we also verified this identity. So I explained you 3 different ways to verify these identities, and you are going to follow this one.